Let's take this timing example. Here, this is a rising edge D flip-flop. You have active low, ClrN and PreN. And ClrN and PreN are also asynchronous. So the initial value of Q is 0 and you're asked to sketch the value of Q. Okay, now let's see what happens. So remember, when ClrN is 0, output is 0, and when PreN is 0, output equals to 1. That is, Q is equals to 0 and Q is equals to 1. And note that ClrN and PreN are asynchronous signals. Okay, now let's look at the first rising edge of the clock. At the first rising edge of the clock, D is 1. However, ClrN and PreN are 1 and 1, which means that they are not activated. Therefore, your output is going to follow D. It's going to be 1 here. It stays 1 for a very short amount of time. Next, remember, ClrN and PreN are asynchronous, so they are not going to depend on the rising edge of the clock. In fact, they are going to override the rising edge of the clock. Here, ClrN is 0. As soon as ClrN is 0, your output is 0. So after a short amount of time, output goes 0. It stays 0. It's going to continue to stay in 0 at least until the next rising edge of the clock, because there is no activity after that. At the next rising edge of the clock, your D is a 0, ClrN is 1 and PreN is 1. So your output stays at 0. Now we see that PreN is 0. As soon as PreN is 0, output is 1. It doesn't really depend upon the rising edge of the clock. So after a short time, output goes 1, stays 1. Our next rising edge of the clock is here, so it's going to stay at 1. At the next rising edge of the clock, ClrN is 1, PreN is 1, and your D is a 1. So your output is going to follow D. Now at this point, ClrN is going to 0, which means your output must go to 0. So after a short delay, output is going to 0. Now this is our next rising edge. Notice that at this rising edge, ClrN is 0, D is 1. Even though D is 1, your ClrN is going to take precedence, which means it is going to override the clock and your output remains 0.